Okay, guys, right now we're going to be doing dosage calculations based on body weight, chapter 31. Our learning objectives are to basically list examples of when dosing based on body weight is important and calculate medication doses based on body weight. Okay, so the body weight of a patient is used in calculating accurate doses of medication, especially for pediatric and geriatric patients, and also for potent drugs such as chemotherapy agents. This method of calculation is considered more reliable than the doses based on age. For the most part, you do want to do a weight dose rather than an age dose. Okay. Doses are expressed as milligrams per kilo or micrograms per kilo per or milligrams per pound of body weight. Okay. So milligram over kilogram or microgram over kilo or milligram over pound. Okay. Conversions from pounds to kilos or kilos to pounds must be made when necessary. So the conversion factor is, of course, 1 kilo is 2.2 pounds. So whenever you see something like the problem states, for example, administer, for example, 20 milligrams per kilogram, you automatically know that whatever poundage weight they give you, you need to divide that by 2.2. So that's basically what that means. Okay. So I'm just going to jump into the problems and kind of explain what's really going on with each situation. Okay, let me just double check, make sure I'm in focus. Okay. All right, so problem number 1 says, this is chapter 31. I don't know if I mentioned that. Okay, so chapter 31 math, problem number 1. Okay, cefuroxime is to be administered 20 milligram per kilogram in an IV every 4 hours. Okay, how many milligram per dose should a child weighing 30 kilograms receive? Okay, so basically it's saying 20 milligrams per kilograms. How many milligrams per dose should a child weighing 30 kilos receive? So the conversion's already done. If you need 20 per 30, you just simply multiply 20 by 30 to get a 600 milligram dose every 4 hours, okay? Because it is asking how many milligram per dose should a child weighing 30 kilograms receive? So the answer would be 600 milligrams per dose. So the child would get 600 milligrams every 4 hours in this case. Okay. Let's move on to number 2. A physician orders a medication available as 500 milligram tablets for a 110 pound patient. The recommended dose for the drug is 20 milligram per kilogram per dose. How many tablets should be given to the patient for each dose? Okay, so first off, we need to figure out, because our milligrams is per kilogram, we automatically want to divide our poundage, which is 110. We divide it by 2.2 to get kilos. Okay, so 110 pounds divided by 2.2, we get 50 kilos. Okay, so now with that, we can read the question, and it says, the recommended dose for the drug is 20 milligram per kilogram per dose. Okay, how many tablets should be given to each patient? Okay, so what we need to figure out is, let's first establish what we need for this patient. So in this case, our patient is 50 kilos, right? And we need to give them 20 milligrams for that 50 kilos. So 20 milligrams per 50 is 1,000 milligram, right? Because we're multiplying 20 for each kilo. So we'll get 1,000 milligram. Earlier in the question, it says the physician, or let me reread the question really quick. A physician orders a medication available as 500 milligram tablets for a 110 pound patient. Okay, so if the 500 milligram tablets is what we have available, we're just going to divide the total amount that we need by 500. Okay, because the total amount that we need is 1,000 milligrams, but it comes in 500. We only have 500 milligram tablets. So in this case, we're going to give them 2 tablets because 500 goes into 1,000 twice. Okay? So, rule of thumb, whenever you have a certain amount of pounds, you just automatically divide it by 2.2 if the dose is in kilogram, okay? Per kilogram per pound, for example. Okay. Let's explain number 3. The doctor orders vancomycin 10 milligram per kilogram, okay? Every 12 hours for an IV for a newborn. The infant weighs 4,000 grams. How many milligrams should be given per dose? Okay, so automatically we want to establish that 1,000 grams is 1 kilogram. So 4,000 grams would be 4 kilograms, okay? So that 4,000 grams becomes 4 kilograms. Okay, and now it says the doctor orders 10 milligrams for each kilo. Okay, 10 milligram per kilo. So something that looks like this, okay, means 10 milligram for each 1 kilo. Okay, I don't know if you can see that. 10 milligram for each 1 kilo. So we have 4 kilos and we need to give them 10 for each kilo. So we gave them 40. So 4 times 10, 40 milligram. Okay, and that's how much your 1 dose would be every 12 hours. Okay. Number 4, a physician orders cyclophosphamide to be given 5 milligrams per kilogram 4 times a day, or QID, in 50 ml of dextrose 5 water, or D5W. Okay. The patient weighs 132 pounds. If the concentration of the drug is available in 500 over 10 ml, how many ml should be added to each bag? Okay, so our first rule is, let's eliminate some extra wordage. Okay, that's how I do it. So we need to give 5 milligrams for each kilogram in 50 ml dextrose water. In this case, the 50 ml dextrose water is unnecessary information for right now. Okay, so first we take our 132 pounds and we make it into kilos. So 132 pounds divided by the 2.2 will make it 60 kilos. Okay, 60 kilogram. And it says give 5 milligrams for each kilogram. So 60 kilograms times 5 would be a total of 300 milligrams total that we need to give. Okay, but it also says now that we have bags of 500 milligrams over 10 ml. So basically every 10 ml bag that we have is, the strength is 500 milligrams. But in this case, we just want to give the patient 300 milligrams. So if we want to give the patient 300 milligrams, we just line up our crisscross. Okay, so remember, like I said, if we have 3 pieces and we want to find out what the 4th piece is, we do a crisscross. Okay, so if we have 510, then how much would we have if we needed 300? So 500 over 10 ml equals 300 milligram over X. Okay, so if you crisscross, you would get your 500X. 500 times X is 500X. And 10 times 300 is 3,000, right? If you divide by 500 to isolate your X and to basically cross out the X, your X becomes 6 ml, okay? Because that's what you're looking for. So if it's 500 for 10 ml, then obviously if it's 300, 6 ml would be correct because it's less than 10 ml, right? So just as a quick reference, like if you got anything over 10 ml, you would know you were wrong. Okay, so 6 ml is what you're giving the patient in this case. Okay. All right. Let's continue to number 5. Number 5 states, a physician requests an aminophylline infusion. The order is for 1,000 milligrams. aminophylline in 500 ml of D5W. Again, D5W is dextrose 5 in water. Let me see if I can just focus that in there and read it from the screen. Okay. If the patient weighs 182 pounds and is to receive 0.6 milligrams per kilos, how many ml will deliver the required dose? Okay. So let me just take you down through an explanation really quick. Our first job is to basically determine that 1,000 milligrams in 500 ml is the same thing as saying each ml in that bag is 2 milligrams. So first off, we write down our facts. 1,000 milligrams in 500 ml equals 2 milligram in each of those mLs. Okay. Our second job would be to create our pounds, or to convert our pounds into kilograms, because that's what we're working with as far as what we're given, because we need to give them 0.6 milligram per kilo. So that's why we need to convert the 182 pounds by 2.2, or divide it by 2.2 in order to get kilos. Okay, so you get to 182 pounds and you divide it by 2.2, because 1 kilo is 2.2 pounds. So that's why you're dividing by 2.2. And you get a total of 82.72 kilograms. Okay, so this is the total kilos. So if you divide 182 by 2.2, you get 82.72. And because you do need to give them 0.6 milligrams per kilo, you multiply the 82.72 kilos by the 0.6 milligrams in order to get the 49.63 milligram answer. Okay. Now, it states that it's asking how many ml will deliver the required dose. Okay. So the required dose is basically 1,000 milligrams. Okay. So if we're giving 49.63 milligrams, if we divide that by 2, you will get a total of 24.8 milligrams. Okay, so let me just re-explain that, because I don't think I made any sense. Really quick. So a physician requests an aminophylline infusion. Okay, so a physician is requesting an infusion. The order is for 1,000 milligrams in 500 ml. If the patient weighs 182 pounds and is to receive 0.6 milligrams per kilogram, how many ml will deliver the required dose? So the 49.63 milligrams is the required dose. Okay, and when we divide that by 2, because each ml is 2 milligrams, we get the 24.8. Okay, I hope that makes sense. Because basically it's the same thing like our previous problem. Our total bag has 1,000 milligrams in it, and it's 500 ml. The size is 500 ml. Okay, so it's 500 ml, and it has 1,000 milligrams of pure powder in it. Okay, but based on this weight, based on these kilos, and based on the dosage that we have to give our patient, the total milligram that the patient should have is the 49.63. And because we're looking for mLs rather than milligrams, we divide by 2, because we know that each ml has 2 milligrams in it. Okay, based on the facts. And that's how we get the 24.8. Okay. All right, so let's move on to number 6. Number 6 states an adult intravenous dose of zidovudine is 2 milligrams per kilogram every 4 hours, 6 times a day. How many milligram will a 180-pound patient receive daily? Okay. And obviously you see the answer there. I just wrote it from my note, but let me just explain how I got that. Okay. So the fact is that the dose is 2 milligram per kilogram every 4 hours, maximum 6 times a day. So every 2 milligram per kilogram, basically by six. Okay. And obviously we have the pounds, but we need to convert it into kilos. So when we have 180 pounds divided by 2.2, because we need to make it into kilos in order to solve this problem, we get 81.81 kilos. Okay, so 180 divided by 2.2 is 81.81 kilos. Okay, all right, so now because we know that the zidivudine is 2 milligram per kilo, we need to divide by or multiply by 2. So 81.81 times 2 would give us 163.63 milligrams per dose. Okay, this 163 is per dose. Okay, now the question asks, how many milligrams will a 180-pound patient receive daily? So if it asked for a single dose, you would say 163.63. But because it's asking for a daily dose, you need to multiply it by 6, because it says that you're going to get it 6 times a day, or the patient is going to get it 6 times a day. So you need to multiply your 163.63 times 6, okay, in order to get the 981.8 milligrams as your answer. Okay. All right, and then I went ahead and did 2 more, just so we can get some micrograms in there. All right, I went on to number 18. And 18 states, a 176-pound patient requires a dose of 5 microgram per kilogram per minute of dopamine. How many milligrams will the patient receive in 20 minutes? Again, we need to create our pounds into kilos, because that's what we're working with, all right? Because it's saying 5 microgram per kilogram. Now, if it was saying 5 microgram per pound, we can leave the 176 as is, but because we're working for kilos right now, we need to convert it. So 176 divided by 2.2 gives us 80 kilos to work with. Okay, so 80 kilos to work with, and then we multiply it by the 5 micrograms that you need for each kilo for each minute in order to get 400 micrograms. So you multiply 80 kilos by 5 micrograms and you get 400 micrograms that is needed for each minute. Okay, 80 times 5 is 400. Okay, now what I did was I took the 400 micrograms that you need per minute, and it says that it's asking how much will the patient receive in 20 minutes. So I got 400 micrograms. I multiply it by the 20 minutes in order to get 8,000 micrograms. Okay? Now, it's asking how many milligrams will the patient receive. So that means now I need to convert my micrograms to milligrams, which means I need to divide by 1,000, because 1 milligram is 1,000 micrograms. So that's why I'm dividing by 1,000. And my answer will end up being 8 milligrams. Okay? Now, if it asked for micrograms, 8,000 microgram would be correct. But because it's asking for milligrams, you need to divide by 1,000 in order to get your 8. Okay? And then I moved on to number 24. Okay? Number 24 states, a physician writes, let me see if I can just do this through here. Okay, well, I'm just going to read it out loud. Okay, so a physician writes, there it goes. A physician writes an order for a 52-pound child, okay, for 400,000 units per kilogram per day in divided doses every 6 hours. Each dose is administered in a 50 ml bag of dextrose 5 water IV piggyback, or IVPB. IVPB is IVPB piggyback, okay? The drug is available as 500,000 units per 1 ml or per ml. How many ml will be used in each IV piggyback? Again, you see my answer is 4.7, but let's explain how we got that. Okay, first off, obviously, we need to determine how many kilos is our pounds. Okay, so our child is 52 pounds. So 52 divided by 2.2 gives us 23.63 kilos, okay? Because that's what we're working with. Now, you need to give this child 400,000 units per kilo per day, okay? So 23.63 kilos times 400,000 units equals 94,54,54,5.2. Okay, so I guess we're like 9,454,545.2 units. Okay, so 23.63 kilograms, multiply that by 400,000 units, okay, that you need for each kilo. You're going to need 9,454,545.2 units. Okay, so it is asking how many ml will be used in each IV piggyback, and you need to divide the doses every 6 hours. Okay, every 6 hours is 4 doses, right? 6 and 6 is 12, another 6 is 24. So every 6 hours is 4 doses. Okay, so you get your 9,454,545.2 units, and you divide it by your 4 doses, because you need to, let's work with smaller numbers, I guess. Okay, and you get 2,363,636.3 units for each dose. So right now you're at each dose. Okay, this is your daily dose, and that is your single dose. Okay, single dose. All right, now your 23,363, if you divide it by the 500,000 per 1 ml, you should get 4.72 ml. But let me just double check. 363, 636.3. And you divide that by 500. 1, 2, 3. Yes, you get 4.72 ml. Okay? Considering the fact that each it's available in 500,000 units per ml, you just need to divide by 500,000 units in order to get the 4.72 ml. Alrighty guys, that's it for chapter 31 for now. If you have any questions on the rest of the questions, I didn't get a chance to go through all of them. It is a little late. I think it's 4 in the morning. So yeah. If you have any questions about chapter 31, let me know. Leave the questions in the comment section so we can answer it just once. Otherwise, we'll see you in the next video. All right, bye-bye.